Okay, hello discrete math students. We're going to, okay, hold on one second. We're going to go over some of the problems in chapter 2 involving sets, especially power sets. All right. And we are going to use, excuse me, we're going to use a racket file that I worked on yesterday and this morning, and I will also email it to you. I understand that racket is confusing for some of you, and that's fine. You don't really have to understand the code. You just have to understand how to use it or how to apply it. You could also do the same thing in Mathematica and in Python. It's your choice. It's your choice. You can use Mathematica, you can use Python, or you can use racket. It's your choice. Okay, so let me cursor over to the problems that have to do with power sets. Okay, hold on one second. Well, cardinality is an interesting question too. So determining cardinality. So what if A is equal to the empty set? Okay, the cardinality is going to be 0 because the empty set is empty, which contains no elements. And that is correct. So cardinality has to do with the number of elements in a set. The empty set has a cardinality of 0 because it's empty. Okay. Excuse me. Okay. Let's see now. Determining cardinality. This is question 13. So here we have the set that includes the empty set. So this particular set will have a cardinality of 1 because it is a set with exactly one element, the empty set. And that should be correct. Okay, very good. Here, let's see now. We have A is equal to a set, and that's going to be the empty set. And then in it, we have another set that includes the empty set. And I believe the cardinality should be 2 because as the empty set is an element and the set of the empty set is the second and different element, and that should be correct. Okay, so the cardinality here is going to be 2. Okay. Let me see now. They're making it a little bit more complicated in this question. So let's see, how many distinct elements do we have in A? We have the empty set, we have the set of the empty set, and then here we have the set that includes the empty set and the set of the empty set. So this, if I'm reading this correctly, yes, this should have a cardinality of 3. This should have a cardinality of 3. And that is correct. Hold on one second. Let me just get some dirt off of my computer. Okay, there we go. And again, this is going to be, let me see if I'm reading this correctly. Here, this question, number 16, this is a little bit difficult to read because, oh, I see what they're doing. I see. This should also have a cardinality of 3 because we have the empty set, we have the set of the empty set, and then we have the set of the empty set and the set of the empty set. So this should have a cardinality of 3. Okay, it's number 16. Okay, wonderful. Now, finding power sets. Now, here, okay, in your homework, they're using this symbol to represent the empty set. But in rackets, we're going to use this symbol, which is the symbol for the empty list. And I'm going to show you that in just a moment, okay? So what is the power set? Okay, find the power set of each of the following sets where A and B are distinct elements. What is the power set of B? Well, that should be pretty easy. Let's run this program. Okay, What is the power set of B? So the power set of B is the empty set and the set of B. And so that's going to be the answer right over there. Okay. And what is the power set of AB? So the power set of AB is going to be, oh, 1 second. Oh, I see. Okay, here, the problem here, okay. So the problem here is I'm using symbols. Okay, I'm using symbols instead of numbers. So, oh, no. Where's, no. Wait a minute. Where did I put my cursor? Okay. Let me reopen this, guys. Don't save. Okay, let me reopen that. Okay, there we go. Okay, so the problem is the way that I'm using my power set function. Okay, so the power set function uses a compare function depending on whether the elements are numbers, symbols, or strings. So yeah, for example, power set, if your set contains only one element, like the set of B, I don't think it really is going to make much of a difference. But if your set contains more than one element, it is going to make a difference. So power set A and B are symbols. So I'm going to have to provide, the proper comparison function so that the output is readable. So this is the function I'm going to use. Okay. So that's symbol less than question mark. It's simply a way of saying, A is less than B, B is greater than A. Just so that I used it, I incorporated it into my function in order to make the output easier to read. Technically, it's not absolutely necessary, but I chose to include it in order to make the output easier to read. So the answer is the null set or empty set, A, B, and AB. Okay. So the answer is right here. Actually, no. That is not the answer. The answer is right over here. The null set or empty set, the set of A, the set of B, and the set of A and B. And that is correct. Let's see. Okay, so this one's going to be a little, this one is a little tricky. We're supposed to find the power set here, and that's definitely going to be a little bit tricky, especially, well, let me see. So we have in racket, this would be the set of the empty set, and then, which I'm representing as the empty list, and this would be that kind of a list. Yeah, that's kind of weird, but let's see if we can do that. I don't know if racket's going to give us the right answer, but we can certainly try. Power set. I don't know if this is going to work, but let's try it. I don't know. Let's see. Yeah, this is not, that's an unusual, okay, hold on a second. Let me, Okay, so let's see what we have over here. This problem is a little bit unusual. So we would have well, you'd have all possible combinations. So you would have this looks like it might be the correct answer because here you're going to contain, okay, here you have the null sets. Here you have the set of the null set. Here you have the set of the null set. And here you have the original set, which is its own subset. So you know what? This is probably going to be the answer. Weird question for sure. Okay, that is correct. Okay, so this one's actually going to be pretty easy. So this one, the cardinality of power sets. So if we have A and B and the set of A and B. Now, this is a little bit strange, but we're going to have, well, this set contains 3 elements, and 2 to the power 3 is going to be 8. Yeah, 2 to the power 3 is going to be 8. So it's the number of elements that you have, and then 2 to the power of that number, and that's going to tell you the cardinality of your power sets. So this should look like power set AB. Well, if you're doing ABC, oh, wait a second, sorry about that. If you're, hold on a second. So if you're doing the power set of ABC symbol, because A, B, and C are being treated as symbols, that's what you're going to get. Now the problem is here C is itself the set of A and B. Now I'm not sure if my program is going to handle that very well, but let's see. AB. Not sure if that's going to work too well. Yeah, because this is not a symbol. This is actually a list of A and B. So yeah, that's okay. So they're trying to trick us with pretty difficult questions, right? Oh, hold on one second. Let's see. So here again we have the cardinality of power sets. How many elements are actually in this set? So we have 1, 2, 3, and 4. 2 to the power 4 is equal to 16. All right. So then it should have a cardinality of 16, which is correct. Here, okay, the power set of the empty set, power set of that. The power set of the empty set is simply going to be the set that contains the empty set, right? And the power set of that, well, let me see. The power set of that is going to be the empty set, and then the set that contains the empty sets. It should be 2. Okay, last one, guys. So identifying power sets. The null set, this cannot be the power set of any set. And that is correct. Okay, guys, so what I'm going to do is I'm going to email, excuse me, I'm going to email this file to you. In general, it'll help you identify power sets. It may not help you very well when each element is itself a set. So for example, you could do something, you could use my function this way, power set, what's a good example? Power set, blue, green, red, yellow. And these are strings. The set here contains this is a set of strings. So my comparison function is going to look like this. This is going to be my comparison function. All right, it's going to look like that. Power set, blue, green, red, yellow. Okay. And so these are all the excuse me, these are all the sets that I can excuse me, these are all the sets that I can derive from this set of blue, green, red, and yellow. So we start out with the empty set. And then, there's the subset of blue, the subset of green, the subset of red, the subset of yellow, the subset of blue and green, and then blue and red, and blue and yellow, and green and red, green and yellow, red and yellow, blue, green and red, blue, green and yellow, blue, red and yellow, green, red and yellow, blue, green, red and yellow. Okay. Now, there are a couple of things. So the function that I wrote, it works very well, but it assumes a homogeneous set. So what do I mean by a homogeneous set? That means that every element of the set belongs to the same type. This is a string, this is a string, this is a string, this is a string. So the assumption being made in my function is that every element of the set belongs to the same type. If you have a set like this, 1, 2, 3, and then the symbol A, my function is not going to work. If you have a set like this, 1, 2, 3, and the string ball, B-A-L-L, okay, the function that I wrote is not going to work because the set is not homogeneous. A homogeneous set means a set where every element belongs to the same type. So the function that I wrote makes the assumption that every element of the set is of the same type. Okay, so that's important. If you throw away that assumption, then the function that I wrote is not going to work too well. In fact, it's just not going to work. It's not going to work at all. It's not going to work at all. Okay, but I will email this to you, and you can play around with it and see, play around with it and see how it works. I know the code is going to look really complicated, and that's okay. That's okay. I know it's going to look really complicated, but eventually you can figure it out. Eventually you can figure it out. And if you're just doing a power set of a set of numbers, that's really easy. 1, 2, 3. And you could provide this as your sorting function, but you don't have to because that's the default. That's actually the default. Okay? So you could provide, this as your sorting function, less than, but you don't have to. You don't have to because it's assumed by default that you're sorting a set of numbers. And then you'll get the empty set, the set of 1, the subset of 1, the subset of 2, the subset of 3, the subset of 1 and 2, the subset of 1 and 3, the subset of 2 and 3, and the subset of 1 and 2 and 3. Also, bear in mind that if you're talking about a set, the set of 2 and 3 is the same as the set of 3 and 2. It doesn't matter which comes first and which comes second. In a set, it doesn't matter which element is first, which element is second, which element is last. So the set of 2 and 3 is the same as the set of 3 and 2. Because the order doesn't make a difference when we're talking about sets. Okay? All right, guys, that's about it. And instead of emailing this to you, I'm simply going to post this to your course shell. I'm not going to email this to you. I'm going to email it to your course shell, and then just do with it as you please. You can download it. You can look at it. Just take a look at it when you have time. Okay? That's about it. All right, guys, that's it for now, and we will communicate at some point in the future. Very soon, I'm sure. Take care. Be well. Bye-bye.